Hello. This short video is going to recap some common questions about the topic of salts, especially the preparation of soluble salts using the excess solid plus acid method. I would highly recommend, before you start watching this video and studying the questions, to study the method itself and the steps to prepare soluble salt using excess solid plus acid. Before I start, I'm just going to give you a quick recap on the method. To prepare a soluble salt using the excess solid method, solid of choice is either one of three things, either metal or metal carbonate or metal oxide. All these three, when we add them to an acid, they produce a salt. Metal produces salt and hydrogen. Metal carbonate produces salt and water and carbon dioxide, and metal oxide produces salt plus water. You need to learn these reactions very well before you move on. Now, what are the acids that we choose from? We choose, if the salt, depending on the name of the salt, if the salt is a chloride salt, we choose hydrochloric acid. If the salt is a nitrate salt, we choose nitric acid. And if the salt is a sulfate salt, we choose sulfuric acid. So if I want to prepare, for example, magnesium chloride, I'm going to choose hydrochloric acid and one of the three salts, either magnesium or magnesium carbonate or magnesium oxide. Now, let's look at the questions. The first kind of question is, why is the acid warmed before adding the solid? So for example, I'm going to prepare magnesium chloride. So I'm going to, in a beaker, add some hydrochloric acid and warm it. And then he asks you, why is the acid warmed before adding the solid? To speed up the rate of the reaction, to make the reaction faster. This applies when we add metal or metal oxide. If I'm adding metal carbonate, we do not warm the acid. You can pause the video and write this comment. Warming the acid doesn't apply with metal carbonates because they react very quickly and we don't need warming. Why do we add the carbonate slowly? If I'm choosing the carbonate method, then I'm going to add it slowly. Why? Because acid and carbonate produce effervescence of CO2. So splashing will occur if I add too much carbonate to the acid. So to avoid splashing, because the carbonate reacts rapidly, producing effervescence. So we add the carbonate bit by bit. Why do we add excess solid? To make sure that the acid is finished, so the salt prepared is absolutely pure. So now I know that the solution is only the salt. There is no acid at all mixed with it. Another way to ask this question is, how do you make sure that the salt is pure? We add excess solid. Why? To make sure that the acid is finished and that the only solution remaining in the beaker is the salt. The next question. What would you observe to show that the reaction is finished? In this question, please make sure you read the question till the end, because most of you write down the observation during the reaction. We want the observation at the end. How do I know that خلاص كده enough solid is added? Fizzing stops, and this applies if we're dealing with the metal and the metal carbonate, because this is the only case where a gas is produced, and the solid means at the bottom of the beaker or the solid won't dissolve. The next question. How is the excess solid removed? By filtration. How do you obtain dry crystals? You will, if the question is 1 mark, you will just say by crystallization. And if he needs more, then you will, طبعا لو قال describe how you obtain dry crystals, then you have to describe the steps. So you have to study the steps of crystallization. During crystallization, how do you know when to stop heating? When we carry out crystallization, we evaporate the solution to make it very concentrated. And then we stop heating and leave it to cool. طب when do I stop heating? When we reach the crystallization point. How do we know that we have reached the crystallization point? We take a sample from the solution with a glass rod. We leave it to cool. If crystals appear, stop heating. Now, why crystals appear when the solution is left to cool? Because solubility of salt decreases as solution cools. ممكن يسأل السؤال, why during crystallization we have to leave it to cool down to decrease the solubility of the salt to make it appear as crystals. وطبعا we dry all crystals between two filter papers. So that's it for this video. I hope it's useful. I will attach with the video the slides so you can use them to study. Thank you very much. Good luck.